Hello everyone. In this video, we are going to be discussing the asteroid collision problem. In this problem, we are given an array of positive and negative numbers. Each of these numbers represents an asteroid. A positive number means that the asteroid is moving to the right, and a negative number means that the asteroid is moving to the left. The magnitude of the number represents the size of the asteroid, and all asteroids are traveling at the same speed. Asteroids heading towards one another are going to collide. When asteroids collide, the asteroid that is smaller is destroyed, and nothing happens to the larger one. If both asteroids are the same size, then they both get destroyed. Our job is to return an array of all the remaining asteroids after all the collisions have occurred. Here is an example input array: -2, 10, 3, -3, and -4. That would represent an asteroid formation like this. So let's simulate what would happen. First, there would be a collision between 3 and -3. Since these asteroids are of the same size, they both get destroyed in the collision. Then there is a collision between 10 and -4. Since the 10 asteroid is larger, the -4 asteroid gets destroyed. After this, there are no more collisions, and the -2 and 10 asteroids are the only two remaining. So this would be the final answer that we return as an array. Hopefully now at this point you have a better understanding of the problem. Let's see how to come up with a solution. So the key to this solution is to not think from the perspective of resolving collisions, but rather focusing on what situations would allow for an asteroid to remain. Let's look at processing asteroids from left to right. Let's say that we are given some asteroids and the first asteroid is a left-moving one. Let's not care about the rest of the asteroids for now. We know this left-moving -2 asteroid is going to be on the final list, and we know this because there are not any asteroids to the left of it that are right-moving and could collide with it. Now let's change this and instead say that this asteroid is right-moving. Well then, not knowing what lies to the right of this asteroid, we can't say for sure if this asteroid is going to remain because it could possibly collide with a bigger left-traveling asteroid. So overall, the observation to make is that if we encounter a left-traveling asteroid and there are no asteroids to the left of it, we can say it is going to be a final asteroid. However, we need to save all our right-traveling asteroids and see if they will collide with anything to the right of them. After making this observation, you might begin to notice that using a stack data structure might be a good idea for this solution. So in our solution, we are going to process the asteroids from left to right. For every asteroid that is moving to the right, we can't make a conclusion on it now, so we push it onto our stack. So for example here, with this 2, that would go onto the stack. And for this 5, we would push that onto our stack as well. Now, for any left-moving asteroid, like this -2 here, what we do is we compare it to the top of our stack. If it is a larger asteroid, we start to pop elements off our stack because this means that this particular left-moving asteroid is going to destroy the right-moving asteroid on the top of our stack. This isn't the case here though. What is the case here is that the left-moving asteroid is actually smaller than the top of the stack. In this case, we say that the left-moving asteroid gets destroyed, which means we keep the top of our stack the same. And we move on to processing the next asteroid, which is a left-moving one of size 6. Again, since this is a left-moving asteroid, we compare it to the top of our stack, and because this time the left-moving asteroid of size 6 is going to destroy the right-moving asteroid of size 5, we are going to pop the 5 asteroid from our stack. We don't stop here though. As long as there are elements on the stack, we continue to compare our left-moving 6 to the right-moving asteroids. So once again, comparing these two, our left-moving 6 is going to destroy the right-moving 2 on our stack. So we pop that 2 from our stack. Now, since there are no more elements on our stack, this means that there are no more right-moving asteroids to the left of this left-moving 6 that this left moving 6 could collide with. And when this is the case, like I mentioned earlier, we know that this -6 is going to be a final asteroid in our answer. So let's save this -6 to an array called final asteroids. This final asteroids array is the array we're ultimately going to return as our answer. Now we move on to the final asteroid, the 4. This is a right-moving asteroid, so all we do is push the 4 onto the stack. At this point, there are no more asteroids to process, so what we do is that any elements still on our stack get concatenated to the end of our final asteroids array. In this case, there is just a 4, so we put that 4 after the -6. However, if there happen to be more asteroids on the stack, like say a 10 and an 11 here, those would go onto our final asteroids answer as well. The reason behind doing this is that the stack represents right-moving asteroids waiting for the left-moving ones to collide with them. But if we reach the end of our input, it means that there are no more left-moving asteroids remaining to collide with the right-moving ones on our stack. So that means the remaining right-moving asteroids on our stack are going to be part of the final asteroids answer. Okay, hopefully this broader discussion helps you understand how you might think through this solution in an interview. But let's get a bit more detailed and look at the code now. So the first thing we do is create our stack and the array for the final asteroids. The final asteroids array is ultimately what we're going to return from our function. Next, we iterate through every asteroid in the input list. If the asteroids are moving to the right, then we just append them to the stack. However, if the asteroids are moving to the left, we need to implement that strategy of checking against the top of the stack. To do this, we initialize a destroyed boolean, which represents if the left-moving asteroid has been destroyed yet. It starts off as false because as of now, this asteroid has not been destroyed, but once it does, we will change it to true. Next is the while loop condition, whose condition is, while there are still elements on our stack and the asteroid has not been destroyed, then we enter the while loop body where there are 3 cases. The first case is if the right-moving asteroid on the top of the stack is larger than this left-moving asteroid. If it is, then the asteroid at the top of the stack destroys this left-moving asteroid, so we flip the destroyed boolean to true. The second case is the opposite. This is if the right-moving asteroid at the top of the stack is smaller than the left-moving asteroid. If that's the case, then this left-moving asteroid destroys the right-moving asteroid, and we account for this in our code by popping the right-moving asteroid from our stack. And finally, we have the else case. This occurs when the right-moving asteroid and this left-moving asteroid are the same size. Then both of the asteroids get destroyed, and we simulate this by both setting destroyed to true and popping the top of the stack. Finally, if we make it out of the while loop and the destroyed boolean is still false, this means that this left-moving asteroid has destroyed all the right-moving asteroids on the stack. If you think back to our example from earlier, this is when the left-moving asteroid of size 6 destroyed the 5-sized asteroid on the stack, and then after that, it destroyed the 2-sized asteroid as well. And then the stack became empty. So in that case, remember that we concluded that since this was a left-moving asteroid and there were no more right-moving asteroids it could encounter, then this asteroid was guaranteed to make it to the final asteroids list, and we should append it to the final list. And that's what we're doing here in our code. Once we process our last asteroid in the for loop and make it out of the for loop, if there are any remaining asteroids on the stack, then we know that these are surviving right-moving asteroids that were not destroyed by left-moving asteroids. So we append those to the end of our final asteroids list. And one thing I should point out here is that this operation of iterating through the stack from the bottom of the stack to the top, you might not be able to do this with a stack data structure in other languages, but because this is Python, and in Python we use a list to simulate the stack, we can do it here. If you are using a language that only lets you access elements from the top end of the stack, then you would have to make a temporary array, pop all the elements in reverse order, and then reverse the temporary array. Regardless of how you do that, the last thing to do is return the final asteroids array. So that is it for the code. Let's go over the time and space complexity of this solution. For time, it is going to be O of n, because inside the for loop is this while loop, which could run n times. The thing to realize though is that the inner while loop can only iterate while there are elements on the stack. And each time it iterates, either we break out of the while loop, or we pop an element from the stack. And that means that over the course of the entire algorithm, this while loop only iterates n times, so we can amortize the cost and say that this is O of n. There's also this second for loop, but again, that can only iterate for the max size of the stack, which is O of n. For space, the extra space we use is the stack. The stack can grow to the size of n. Think of the worst case where all the asteroids are going in the rightward direction. So O of n is our space complexity. Okay, now that we have discussed the time and space, that is actually it for this video. This is the most optimal solution that I could come up with, and it seems to be the best one I could find online as well. But if you do come up with a better one, feel free to explain in the comments. Thank you for watching. I hope you found this video useful, and good luck on all your interviews.